well, students, we want to continue with our class. The topic we are looking at today is rotational equilibrium. So far so good. I've discussed translational equilibrium with you, and I want to just remind you again the necessary and sufficient condition that must be satisfied before you can say a system or a body is in translational equilibrium. Number one, the sum of the horizontal components of the force must be equal to what? 0. Number two, the sum of the vertical component of the forces must also be equal to 0. And number three, the resultant force must be equal to 0. When these conditions are satisfied, then you can say that a body or a system is in translational equilibrium. And I've used that to solve questions with you. Today, we want to look at rotational equilibrium. A force, when applied to a rigid body, tends to produce motion. That's what happens when you apply a force to a rigid body. That body tends to produce what? Motion. But if it is not sufficient, that if the force is not sufficient to cause the rigid body to move, it at least tends to cause a turning effect on the rigid body. You see that the force is enough to move the rigid body, or at best it may cause a kind of turning effect on that rigid body. This turning effect on the rigid body is what is referred to as the moment of the rigid body. The moment of the rigid body. Turning effect, we talk also about moment of the rigid body. What do we mean by moment? As physics students, you will recall if you have been taught, and if not, please pay attention. The moment of a force about a given point is the product of the force and the perpendicular distance drawn from the given point to the line, from the given point to the line, okay, of action of the force. I take that again. The moment of a force about a given point is the product of the force and the perpendicular distance drawn from the given point to the line of action of the force. That means mathematically, you can define moment as force multiplied by perpendicular distance. Please take note of this. Mathematically, moment is the force multiplied by the perpendicular distance. That's number one thing. Please put this in your medulla. Number two, a body is said to have rotational equilibrium under the action of forces if the algebraic sum of the moments of the forces about any point in the plane is 0. What do I mean by that? When you take the sum of all the moments about a given point, okay, on the body, if the sum of all the moments about that given point is equal to 0, then you say that body is experiencing a rotational equilibrium. This is different from translational equilibrium. For rotational equilibrium, the summation of MA is equal to 0. What do I mean by M? M stands for moment. And this subscript A is the point where you are taking the moment from. So meaning you can read this like this. The moment of the forces about point A is equal to what? 0. When that happens, you see the body is having a rotational equilibrium. Again, as we mentioned, this number 3. The necessary and sufficient condition for a system or a body to have rotational equilibrium is that you have summation MA to be equal to 0. And this mathematical expression is what is referred to as the principle of moment. That's another thing we call it a principle of moment in physics. And what is the principle saying? What that principle of moment is saying is that the sum of moments about a point is 0, or you simply say the sum of the clockwise moments is equal to the sum of the anti-clockwise moment. That is what we call the principle of moment, and this principle is needed to solve problem. Is what we actually need here to solve problem under rotational equilibrium, unlike the translational equilibrium that you need summation px, summation py, and your r to solve problem. But here what you need is summation ma, which must be equals to 0, or better still, you can say the sum of the clockwise moment must be equal to the sum of the anti-clockwise moment. Now let's look at this simple example. Example number 1. Weight of 4, 6, 5 newtons are suspended from a uniform beam AB 2 meters long, weighing 3 newtons at distances half meter, 3/4 meters, and 1.5 meters respectively from A. The beam rests on supports at A and B. Find the pressures on the support. That is the question. Now, the first thing you must do whenever you are giving question on either translational equilibrium or rotational equilibrium, diagram is very, very important. You must first of all sketch the diagram. If you sketch the diagram, the problem is half solved. And how do we go about it? Take note of this word. This question here, this question say uniform beam. Uniform beam. When do we say a beam is uniform? A beam is uniform when the center of gravity of that beam is at the center. Okay, when the beam is having this center of gravity at the center, that is at the midpoint. For example, in this question, we are told that AB is uniform beam, and the weight of AB is what? 3 Newton, and AB of course is 2 meters long. Now come back to this diagram. The first thing you need to do is to locate the weight of that beam, which is 3 meters. If you add this together, 0.5, 0.25, 0.25, it will give you exactly 1 meter. Since it's uniform beam, the weight of the beam we add at the midpoint of that beam, and that is why it is called uniform beam. For every uniform beam, the center of gravity of that uniform beam is usually at the middle, and that is why you have these 3 Newton meters situated or located at the midpoint. Now let's go back to the question. I told you it is very, very important you sketch the diagram. We are told that weight of 4 newtons, 6 newtons, 5 newtons are suspended from a uniform beam AB 2 meters long with this weight at these distances half meter. That means the 4 newton meters, 4 newton weight was hung at a distance half meter from point A. Now come back here. This is the end. This is where you have your point A. This is our point A. This is the beam AB. See this length and this point A. And the 4 Newton meters location is here 0.5 from this point A. Then we are also told that the 6 Newton meters is 3/4 meter, which is 0.75 meter. Of course, you just measure from from A. So from here to here is 0.25. So this is where you have 6 Newton meters. Of course, the distance between the 3 Newton meter, which happen to be the weight of the beam, will be 0.25, which is this. Then we are also told that the other force, which is 5 Newton meters, the other force, let's go back to the question. The other force, which is 5, is 1.5 meters away from A. This is 5 Newton force. Is 1.5 meters away from A. Of course, from this A down to this place is 1.5 meters. So the remaining length is 0.5 meters, which is the distance between this 5 Newton and this and B. Please, this is 5 Newton. This should be N, not M. Correct that. So this is the diagram. Now, at these supports where you have A and B, we are told in that question that the beam is having support at point A and B. See it? The beam rests on supports at A and B. We have to find the pressure at this support. So I use this to represent the pressure at the beam A. This is the force going up, and I use this to represent reaction at A, and this to represent the reaction at B. They are the two things we are asked to find in this question. So how do we go about this? I haven't drawn the diagram. The next thing is to now come back here. Now I will start by taking moment either from A or from B. In this question, I am starting with A, taking moment from A. What does it mean to take moment about point A? It means you will remove this pivot, this support, so that there will be movement. There will be movement due to these forces. You know, as it is, the beam cannot move because of the support where they are located. So if I remove this one, I'm taking moment about A, and I remove this support B, of course there will be forced to be movement. Now, and I'm going to use the principle of clockwise and anti-clockwise movement to solve this problem. Let's start with, I'm taking moment about A. Now if you look at this force RB is moving this up in this direction, is going up this way, and that is anti-clockwise direction. It's going up this way. See, it's going up, okay, that way. That's anti-clockwise direction. So that is why you have this RB multiplied by the perpendicular distance from the point of action. We are taking moment about this point A. The distance between this B and A is 2. That's how we got this 2. Equals to the clockwise moment. This one is anti-clockwise moment, while all what you have here, they are called clockwise moment. Let me put you through that. See this first Newton, 5 Newton force. The distance between this 5 Newton force and A is your 1.5. So that's why you have 5 multiplied by 1.5 plus the next one is 3 Newton force. This is also clockwise. It's going this way. It's moving this way. It's moving this way. That's clockwise direction. That's 3 multiplied by 1. Okay, if you add the distances, you get 1 meter. Okay, plus the next one is 6 Newton. This is also clockwise direction. It's going this way. That is 6 multiplied by 6 times 0.75, and plus the last one, which is 4 Newton force. That is 0.5. So 4 times 0.5. So this is the principle. Clockwise moment is equal to anti-clockwise moment. Here is your anti-clockwise again, while you have all this as your clockwise moment. So if you simplify this, you get this as 7.5, this as 3, this is 4.5, and this is 2. From there you make your RB the subject, and that will give you 17/2, which is equal to 8.5 newtons. So this is the pressure at point B. I can go ahead also to find the pressure at point A. That is, I want to find this pressure RA. In this case, if I'm taking this, now if I want to find this pressure RA, that means I will take the moment about point B. I will do away with this support, remove this support. That will make this beam to move in this direction because of the weight. Now look at this. In this case now, all this weight 4, 6, 3, and 5 Newton will move in this direction, in anti-clockwise direction. It will move this way. They will all move this way. They will make the beam to move this way. Whereas you have this RA. This RA, which is moving upward, will move in this will move in clockwise direction. All this will move in anti-clockwise, while this RA will move in clockwise direction. So let's go back to that, where you have taken moment about B. So you have 2 times RA equals to 4 times 1.5 plus 6 times 1.25 plus 3 times 1 plus 5 times 0.5. Okay, so that's the principle of moment that I'm using. So you have 2A equals to 6. When you simplify this, you get 6. This will give you 7.5, and this will give you 3, and this will give you 2.5. And if you make RA the subject, from that expression, you have RA to be 19.5 newtons. So these are the reactions at the support. RB is 8.5 newton, while your RA is 9.5 newtons. So these are the two, the support at the pressure at the two support. But I want you to just take note of this. You can use another method to determine to find your the pressure. If you know one pressure, you can find the other. Remember the third law of motion. This third law of motion can also be used. And what is the third law of motion saying? Is that to every action there is equal and opposite reaction. In this sense, it's talking about the sum of upward forces in that diagram must be equal to the sum of the downward forces. Let's go back to the diagram. The sum of the upward forces must be equal to the sum of the downward forces. You can use that principle also to solve problems like this. Look at this. These are the upward forces. This one, RA plus RB. This is the second force here. These are the only two forces acting upward. Then the downward forces are these 4 plus 6 plus 3 plus 5. These are the downward forces. So the sum of the upward forces must be equal to the sum of the downward forces. Now from that expression, you can form an equation there and solve for any unknown as you wish, depending on what you want to look for. Look at this. You have this RA plus RB equals to 4 plus 6 plus 3 plus 5. Now our RB, let's say we want to find RB9. RB is 8.5. I've calculated that value to be 8.5. All I need to do is to substitute for RB inside this expression and now solve. Then I can find my RA to be 9.5 Newton, which is the same answer we got there. So that is what we are talking about. That is what we have exactly in the as our support, pressure at the support. So please, you can either use the principle of movement directly, and halfway when you get one of the reaction, you can now use this third law of motion, sum of upward forces equals to sum of downward forces, to find the second pressure. You can do it that way. Thank you.